Now what is the use of plotting this distance time graph? One, I told you that by looking at the graph, whether it is a straight line or a curved line, it gives you an information whether the object is in uniform motion or non-uniform motion. And secondly, it helps us to calculate the speed of the object. If you see the graph here, it shows the object moving with uniform speed. It's a straight line from the point O. So in case the object is in uniform speed, then the slope of the graph will help us to calculate the speed. Now what is slope and how can we calculate speed? Let's see. If you just see the line from O, we have got a straight line. Now just consider 2 points A and B in this line. And now we will draw a parallel line to the x-axis from A and another line from B which is parallel to y-axis. Now when you extend both these lines, they will appear to meet at a point, and let's name this point C. So when you join this point with A and B, you get a triangle ABC. So AC, if you see AC, it denotes the time interval, which is T2 minus T1, the time from T1 to T2. Whereas BC, if you look at BC, if you see the corresponding figures on y-axis, you can see it corresponds to the distance S2 minus S1. So as the object moves from the point A to B, it would have covered a distance S2 minus S1 in the time interval T2 minus T1. And we have already learnt that speed is calculated using the formula distance travelled by time taken. So here through this graph we can calculate speed using the slope, which is V equal to distance travelled, which is S2 minus S1, divided by time interval T2 minus T1. S2 minus S1 corresponds to the same length BC and T2 minus T1 corresponds to AC. So V equal to BC by AC. So the quantity BC by AC is called as the slope of the graph, which gives the value of speed when an object travels with uniform speed. Now let's try to find the slope and speed in this graph. So I am taking 2 points A and B, and now I am just trying to join them. So if you see, we know that the slope is nothing but, I'll just name it as C, this point. We know the slope is nothing but BC by AC. If you see BC, the value is 40. See the corresponding speed here, 40, 30. So BC will be 40 minus 30, which is 10 meter. And AC, if you see, corresponding time, which is 20 minus 15, 5. So this is a slope, and if I calculate the value, 10 by 5, which is 2 meter per second. So this gives the speed of the moving object. So the slope is BC by AC, 10 by 5, and we have calculated the speed as 2 meter per second. I hope it was clear. Now see these graphs, we will try to find the type of motion of these objects. If you see the first graph, you can see it is a distance time graph, and as the time progresses there is no change in distance. So this gives an example for an object which is at rest or which is stationary. So as there is no slope, as the slope is 0 and you can see the line is parallel to the x-axis. So speed of the body is 0 and the object is at rest. See the second case, as we have already learned, we are getting a straight line. So this represents an object moving with uniform speed or uniform motion. In the third graph, if you see that the speed or the velocity, it keeps on increasing with time. So whenever there is a change in velocity, we know that the object has acceleration. So this gives an example for an object with accelerated motion. So the slope of the object keeps on increasing with time. And if you see the last graph, initially if you see that the velocity of the object increases and then slowly it reduces. So this gives an example of an object which shows retardation after a certain period of time. In the second case, where the object is moving with uniform speed, what about the acceleration? Any guesses? Since the object is moving with uniform speed or uniform velocity, there is no change in velocity. So acceleration will be nil or 0. So children, I hope you enjoyed learning about distance time graphs. So tomorrow I will meet you again with velocity time graphs. Until then, bye.